Razvan.
Hi everyone, my name is Razvan, as Alex said, and I'm one of the OpenSIPS core developers. I've been in the project for I think it's 8 years now, and looking forward for more.
Money?
For more years. Now, today I will be talking about full Anycast support in OpenSIPS. This is something that we've been working on for a while, and we finally made it work. I will show you how. Okay, so who knows what Anycast is and how it works? Okay. So basically, in Anycast, you have the same IP assigned to different machines, and you use these machines for different reasons: failover, high availability, for geolocation. But as you probably know, there's no easy way of using the same IP on different machines. That's why you probably need a router that knows how to do this. So Anycast is used for different purposes. I will show them later, where you have the same IP assigned to multiple machines, and you use a router or something to either balance the traffic or send it to a single machine, not to all of them. You do this using the BGP protocol, which is a routing protocol, and basically using this protocol you can give them different metrics. You can assign an endpoint different metrics that can be used for balancing traffic. Well, there's no connection state maintained. What does this mean? It means that you can do Anycast with TCP. Although you could, but it's not very easy and it's not actually deployed. I've never heard Anycast TCP story. However, I've heard many UDP-based stories, and as SIP is primarily based on UDP, that's why we are talking about it today. So, why is Anycast important? Well, first of all, it offers geographic location redundancy. So imagine that you put all your eggs, all your servers into a data center, and that data center is hit by a hurricane, let's say. Well, you've probably lost your business. So it's a good idea to have the same setup, the exact same platform, also in a different data center, so that when that data center goes down, you'll still have your service up and running somewhere else. Another thing that can be easily obtained is having the geographic presence of your servers. You can easily minimize the latency towards your server. For example, if you have a bunch of customers that you really want to offer good quality, just set up a server near them. The same server with the same IPs, the same setup, just put it over there, and you'll offer the same. You'll offer better quality for your platform. So basically, Anycast is used for ensuring geographic presence in different places. It's also primarily used for load balancing your setup, and can also be used for high availability. Now, as I said, I've heard a couple of stories about Anycast and SIP Anycast. I will go through them. One of them is using a Statelets Proxy. Basically, that's the simplest way of deploying Anycast in SIP. You have here multiple servers, multiple proxies. Here, the blue circle is an Anycast IP. As you can see, is present on each server, and each server has its own unicast IPs. Now, when an invite comes from the customer, basically you send it to whatever the router chooses, for example this proxy, and then send it further to the endpoint. Well, here we have let's say PBX or something. When the 200 OK when the call is responding, the 200 OK might land on different servers, right? So, for example, it can come here, but since it's a stateless proxy, you don't really care. You just take the VI information and route it to the customer. ACK might again end up somewhere else. Again, you just take the request URI or the routing information and send it to the customer. You don't really care if it's stateless. Another setup that I've seen and I've heard of is only used for balancing. So again, you have the same setup. The first invite hits the Anycast IP, but the next invite is sent over from, as you can see, from the Unicast IP. So this means that when this call is answered, the 200 OK will go to the same Unicast IP, and then you send it further to the client. The acknowledgement, the ACK, also lands on the Unicast. So the entire call will now go through this Unicast IP. There's also a nice routing protocol called ECMP, equal close multipath routing, that allows you to send a request on the Anycast IP, send it further, but when the reply comes in, it will basically make a hash and make sure the router itself will make sure that the reply will also hit the same instance. However, what's the problem with this approach? Do you see one?
What happens if the node goes down?
Exactly. What happens if this node goes down? Well, of course, the protocol can't solve this problem, right? So we have to solve it somewhere else. So these are the limitations of the current stories I've heard. All modern proxy nowadays are stateful. I don't think I've seen a setup with a stateless proxy. Basically because, well, you definitely want to handle retransmissions, for example, or to determine whether the request did reach your servers. So you have to detect timeout, and this is done using stateful, like transaction-wise matching. There's no high availability for sequential messages. For example, if you go back to the second solution, this one, where you stick with the Unicast IP, again, if this machine goes down, your entire call is lost, right? You can't generate proper CDRs, you can't do anything. And if you're doing this, it's not actually a fair load balancing because, well, it's only balancing the first request, because any request that comes somewhere else, I mean, there's no a request cannot go somewhere else. It will always go here, so it's not quite fair. Not part of fair load balancing. So based on these stories, we try to analyze the problem and understand what was going on and how can we solve it. Let's see what's going on. So again, any request can reach on any of these servers. So imagine this scenario where we have an invite, and the invite is sent to the client, but the answer goes on this server. Well, in a stateful proxy, this guy doesn't really know what to do with that 200 OK because it cannot find a running transaction. If it doesn't find a transaction, it will decline it because he doesn't know what to do with it. Well, he could know what to do with it, but by default, OpenSIPS will decline it. If it's declined, what happens? Well, this guy doesn't receive an answer, so it will start retransmitting invites. This guy will send it further. It will again start retransmitting. This guy will send the 200 OK for the retransmissions, but the call will never complete. So basically, that's the main problem with Anycast. And how would you solve this? Well, the short answer is, let's try to replicate the transaction on all nodes. Well, that would be easy, but it's not. Why? Because replicated transaction, a transaction is basically something very, very complex. besides the huge data that it uses, for example, because you have to keep all the colors or color information, callee information. Basically, you can use multiple branches, so you have to store that as well. The data is also volatile. It's very volatile. Invite transactions have multiple provisioning, and based on that provisioning and on the replies, the transaction state changes, and so forth and so on. You also have to replicate all the messages because, for example, you might need to do some retransmission. So replicating transaction is very, very, very ugly, and we try to somehow prevent this solution, or let's say try to find different solutions. And we came up with these two solutions. First of them was, we call them lightweight and full Anycast. The lightweight is basically based on events. So again, we have this, this call, invite, the call is answered, ends up on different machine. Well, this guy then sends an event to the guy that originally created the transaction, just so that he updates his flags, he updates his states, and so on, just to make sure that this transaction doesn't start retransmitting invites, right? And then he will send a 200 OK down to the destination. Well, that's one approach. However, the problem with this approach is that the transaction is only present here. So here, you don't have enough information about the transaction to actually make any changes. For example, a simple, I don't know, a simple example is whether you will need to engage RTP proxy or not on this leg, because that's what you decide on this leg, right? So you don't have this information here. That's one limitation. Any AVP here on 200 OK will not be available because, again, you don't have transaction there. So this is actually not a full, complete solution. That's when we thought of a different approach. So instead of sending the event, why don't we send the entire message here? Because he's the one that knows what to do with it. He has the transaction and all the information necessary to properly complete this call. And when this guy receives the entire SIG message, it will send it the 200 OK and will act based on it. Again, that's why we chose this solution. So this is the solution we chose. As I said, the transaction is always stored where the first request comes in. So when the invite comes in here, the transaction is only stored here. Any message received by any instance, because there might not be only two, there might be, I don't know, 8. Any message is sent to this guy, and this guy is the one that responds. Is the next slide. Okay. This way you can process all the messages with all the with the full transaction context. And the question was, how do you know where to send it? It's quite simple. It's a SIP, let's say, tree. Here, when we send the invite in the via, we just add a CID, a cluster ID we call parameter, let's say, to node 1. When this guy responds with a 200 OK, he must use the same parameters in the via. He will send it to this guy, and that's how he will know where to send it. So up until now, there's no need to replicate any information because this guy has all the information, like the node information, inside the SIP message. Well, we use two different modules besides the transaction module, which is the one that handles transactions. We use two different modules. First of all is the Plasterer Module that my colleagues will be also talking about it, and Bogdan already talked about it. We use the Plasterer Module to group these nodes so that you can easily add a new node. You can easily change the topology. So whenever you want to have a new node, just power it up and it will work out of the box. And use the binary interface for replicating the messages. So when the 200 OK, for example, ends up here, we just send it to the right OpenSIPS instance. That's what we are using, the binary interface. Unfortunately, that's not enough because there are some exceptions. So imagine this the following scenario. So you have this invite goes here, this invite goes here, but then there's a cancel. Well, this cancel gets here. Well, you don't have any VIA information in this cancel because on this leg you don't have any parameters that you can attach. So you also don't find the transaction here because there's no transaction. The transaction is only here. So what could you do? Well, one idea was this guy to advertise, for example, say, well, transaction with this identifiers is here. That was one solution. The other solution is to broadcast this cancel to everyone. Which one did we choose?
Broadcast.
Broadcast, yeah. So we chose the broadcast. Why? Our discussion was if you start working with Anycast, you'll see that these network changes are not that often. So they only happen once in a while. So this means that you probably only use the information when something is bad. Well, it's not always bad. So you don't really want to publish information based on the transaction information every single call. You just want to do it when something is bad, right? That's why the broadcast is basically more lightweight because you only broadcast when a cancel comes in that you can find a transaction for. So it's in our opinion is the right approach. If anyone decides that the other approach is better, we can definitely make that one as well because it's not that hard. It just puts a lot of load on the network and bandwidth because there's a lot of there will be a lot of messages involved. When we broadcast this, only the instance that actually knows about that transaction will match it. So in this case, although he will receive the cancel, he won't be doing anything with it because he doesn't find the transaction. So only this one will find the transaction and he will send the cancel further. The same thing happens with ACK. So the acknowledgement, again, we don't. It's not generated by the user agent server, so we don't have the VIA information in it. So we simply broadcast it. It depends. It also depends if it's an end-to-end ACK or hop by hop, because if it's end-to-end, we already have the routing information, so we don't really need to replicate it. Another exception is the reinvites. So imagine that the call starts on one leg, and then starts a reinvite is sent to a different leg. Well, that's actually even more complicated. Although the first solution, the one that advertises where the transaction is, solves it, we didn't implement that solution, and we rely on the upstream, on one of the upstream gateways to detect this retransmission and solve the retransmission problem. Now, so this is how the Anycast solution works. Basically, we will have three cases. You receive an invite, you send it further, create a transaction, send it further. You receive a reply, you just check whether you have a transaction for that reply. If you don't, just send it to the node that has it. Otherwise, if you have the transaction, route it properly. If you don't have a transaction for it, it won't even get to the script, because it's not worth getting into the script on the current node. So now, transaction-wise, we are all sorted out, right? However, that's not all. probably all of you know that in order to do proper billing, you will need CDRs for your calls. And but first of all, let's see how a call works from the dialog perspective. So we have an invite here, which is sent further to one of the servers that you are, one of your PBXs or whatever. The 200 gets here, but the ACK, which is a sequential message, gets here. So in order for this guy to know how to send it, well, you have routing information, which is enough. But what if you are doing topology hiding? Well, you have all the routing information inside the dialog. So basically, you have to replicate that entire dialog information to everyone. And this is what's done here. Basically, these red stripes show that the dialog information is broadcasted to all the running nodes. This way, when the byte goes in, this guy already has the information about the dialog. So as opposed to the transaction where we don't really want to replicate transaction, dialogs are fully replicated over the binary interfaces. Also, we are also using the Plasterer Module to do that. The Plasterer Module is, ideally, you should use the same cluster that you are using for Anycast nodes, because otherwise Anycast nodes might receive dialogues or messages for dialogues that they are not aware of. Again, as opposed to transaction replication, all dialogues are replicated in the entire cluster. But the replication is done fairly efficient, because dialogues are not that volatile as transactions. You only create a dialog when you get the 200 OK, so basically you know that that transaction already completed, or you know the status for that transaction or that call. So that updates are only triggered when the transaction state changes. Well, this means for a call it's just like two messages broadcasted, because updates are fairly rare. One other thing that we are using and that we really need is dialog tagging. So each dialog is assigned a tag. That's because a dialog is present on multiple nodes. The same dialog is present either by replication or received, generated by SIP messages, but you have them in different nodes. So what we are doing is when a node comes in, it has a tag assigned. Only one instance can have, actually all the nodes know all the tags involved in the platform, but only one instance has that tag active. We need this information because only the active instance is able to take decision based on that dialog. For example, if we need to time out the dialog, we don't really want all of the instances to time out the dialog and all of them sent by to the customer, right? Only one. In our case, only the active instance will do that. This way, when a node crashes, someone else has to become active, right? Currently, we are not doing that automatically because electing a node for becoming active is not that easy. We just offer APIs or MI commands to manually move it based on we are doing this right now based on some SNMP statistics. However, you must ensure that there's always one active node in for one specific tag. Otherwise, the dialogues will never be expired, and of course the CDRs will never be generated. So, in conclusion, if you want to have a full Anycast setup, you can easily use OpenSIPS. I'm not sure how many of you already read my article about Anycast. You will probably see that it's fairly easy to deploy. All you have to do is configure a clusterer. That will, configuring this cluster will also provide high availability, and it's very easy to deploy. All you have to do is like a few lines of code in the OpenSIPS script, and you have it. However, you still have to handle the networking part of Anycast, which actually requires a router that is aware of Anycast support and BGP, and that's something else that I did not address in that article. I know somebody else done it. I think it's here. Is it? See? Yeah. So, yeah, that's my presentation. Just use OpenSIPS if you want to do Anycast the right way. Thank you very much. If you have any questions.
Thank you, Razvan. Okay, who's got some questions?
Eric.
Hey, Eric.
So I have two questions. The first one is, as far as replicating the dialogues for sequential request handling and CDRs and stuff like that, is there a significant advantage to doing that versus simply following a similar model to what you're doing at the transactional level and routing the dialogue to all, or not dialogue, sorry, replicating the message to all nodes? So in the case where you get a buy, it routes to a different node than where the active dialogue is, instead of having dialogue replication set up by the cluster, is there an option to simply just send the buy to all nodes in the cluster?
Let's say by manually, I mean you can manually send the buy and have the same behavior. You can build it manually. This is done automatically right now. And the thing is that it's way lighter to do it using the replication because, well, of course, you know, a buy has, I don't know, let's say 500 bytes, right? You don't really want to send, and besides that 500 bytes, you also need to send, for example, networking information because the other guy doesn't have them. You don't know where the IP the buy was sent from. So you still have to add that information. But you can do this. Vlad, my colleague, already built some script commands that you can easily use to send messages in the cluster. So to broadcast both broadcast and unicast messages. So this can also be done manually.
Okay, but so that part's not built into the Anycast support in the same way that it is for like a cancel at the transactional level. Okay.
No. But you can manually do it. Just
right.
If it's a buy and I don't find the dialog here, just broadcast it. That's it. You can do that in the script.
And so could you do that without modifying the buy headers, just by doing like an SL stateless, I guess?
Yeah, yes, you can do that as well.
Okay. And then my second question is, so right now we distribute via GeoDNS so that you resolve it on sit.com and it depends on where you are based on your geography. And so if I want to decommission a server for whatever maintenance or something like that, I pull its IP from the zone, wait for the calls to drain, and things like that. I'm trying to think of how that would work in this case, and that, like, if you pull a node, if you can't, well, I don't know, maybe I'll leave you to answer the question.
It's very easy to pull a node. All you have to do is just advertise bad metrics for that node. So basically you would advertise bad metrics for that route, for that specific machine, and you send that to the router, and the router will not choose that machine anymore.
So you do it at the router level versus...
Yes, on the BGP level, yeah.
Okay.
So on each machine you have a client, a BGP client that advertises addresses based on some metrics,
right.
And you can hook there and just lower the metric just so you have...
And so I'm talking about on a larger scale, because I think about this in the case of, doing this for servers across the country where I'm not the one who's actually in control of the router that's going to get them there. So it's like someone else's ISP is going to do, like I'm talking about Anycast with, on the public IP network. Right. So, you control our router, what we announced as far as our IP addresses, and we pull that from our thing. But I was thinking about caching and things like that. I don't know quite how that works as much as I do about DNS caching.
Well, you have. I think you have bigger problems with DNS caching than routes caching.
Okay.
At least that's my opinion.
Okay.
You don't have to laugh at it. Jeez.
No one has another question
There's
after
one
that.
question over there. and one
Oh,
here.
somebody does have a question, but this gentleman in the back has priority on you. He combs his hair.
Just to kind of continue on from that, what you're saying, how are you telling the BGP process to basically pull this client out, pull this server out? So you say OpenSIPS this crashed itself, but you're still advertising that IP.
You can do that too. So you'll have a daemon, I think it's called or something like that, that is running on
BGP.
That's probably a different implementation. So you have that daemon that is running and it's actually advertising the routes. You can plug into it and just say, well, now.
Have you got any integration between the two? So if that daemon stops,
yeah, you can do that as well.
stops,
Yeah.
then withdraw.
You can stop the server and he won't publish the routes anymore.
Yeah.
You can do that as well.
But there's no talking between the two daemons just yet.
Not as far as I know, but they can probably be. Actually, I'm pretty sure they can communicate. They can, for example, pull information from OpenSIPS and decide what messages to send. Yeah, I'm pretty sure that you can use the skills of that. It depends on the BGP implementation you are using. I mean the client implementation you're using.
So, I mean, at the end of the day, you're kind of updating a state machine, right? So that's not distributed to a certain degree. You have a state that can be updated from multiple places. And at least in my mind, a state machine can only handle one event at any given time, otherwise you end up in a weird situation. So, how do you handle cluster-wide locking? So you don't get two events trying to update the same dialog state.
Oh, the same, well...
Because, I mean, you could, let's say, get a cancel and two on at the same time. I mean, there's a lot of scenarios when this can happen.
Yeah, that's because these scenarios usually come at the transaction level, and transaction level is sorted out by having the transaction in a single place. However, on dialogues, yeah, that might also be some concurrency problems.
So how do you merge them to different replicas that now have different?
Basically, we don't do that. I mean, usually, so these events are not that the concurrency on the dialogue level is not that, doesn't happen that often. So
yeah, we see quite frequently. It happens many times a day for sure. Like a reinvite happens at the same time as like.
Yeah, a reinvite doesn't actually change the dialogue state. I mean,
it depends on the target update, or right selection. I mean, it could be a lot of things. So, I mean, at the end of the day, you're changing the same development data.
No, I totally agree, because you can also have concurrency whether you are, let's say, processing the events in a different order or something like that. But yeah, we are not handling that. We were thinking of handling something like link state or something like that, just to make sure that the events are properly propagated in order for everyone. But to be honest, we didn't have that many issues with that right now.
Behave.
I will behave. My question is about the transaction variable and dialog variable. Are they being a part of clustering replication?
So again, from the transaction level, you will see them in the script because all the messages will be processed by the instance that initially received the message that created the transaction. So you will definitely see all the variables. In case of the dialog, you'll have to replicate that, but that's already done. I mean, if you change a variable on one server, all the servers will see the same.
So it's going to be bi-directional.
Yes, yes.
Thank you.
Thank you. Wow. There's one more for me if you have time.
Mr. P. Kelly, one of our future speakers.
It wasn't clear what was happening with the reinvites. I know you mentioned it during a transaction that the terms OK would be handled by the initial machine to handle the invite. What would happen with the reinvite?
So as I said, basically we haven't done anything with it, and all we, let's say, that it will be sorted out by this guy. So if an invite comes here, we will definitely send it here. But this guy should be able to detect the retransmission.
I was just thinking of when you were talking about an RTP proxy being engaged or disengaged, would it not be important to ensure the re-invite makes it through the original SIP proxy?
Oh, just a second. You're talking about re-invite or retransmission?
Re-invite.
Oh, sorry, I was talking about retransmission. Well, the re-invite will, you will have all the flags and all the dialog level variables on each server. So if you mark the flag, this guy has the RTP proxy or RTP engine engaged, you will be able to know whether you have to engage or not.
But it may be that one of the OpenSIPS machines doesn't have access to the same RTP proxy as the original, and that may be a detail.
Well, yeah, I think it's a setup problem if it doesn't have access. You could still, of course, you can store, let's say, this is the RTP engine that we used for this call, and keep the same one.
Yeah.
But you definitely have to make sure that it has access to that. Otherwise, I don't see how that's possible. Well, I guess no, I don't see.
Well, it will create a new session. It's a re-invite.
Actually, I think Maxim is right. Yeah, he will. It will. You can also use a different machine.
Yeah, and create a different media session.
Yeah, and you'll just change the SDP, but that's completely that's completely supported by the SDP standard.
Any other questions? All right, let's give a round of applause to Razvan.